basic, and even if I'm not sure here in section 7.5 with these graphing square roots, it's not going to be like where we got to deal with slope and y-intercept and all that business. We're going to let the calculator help us put in some points and kind of just go with this. So here's how this works. This funky looking graph right here is a basic graph of this equation, y equals the square root of x. You're like, now, you know, how's this going to work? There's some points on here, okay, at 0, 0. And I'm just going to label the points on here. You won't have to do this on your regular graphs, but I just want you to see where they're coming from. Basically, if I was looking at a chart with these, so I got 0, 0, 1, 1, 4, 2, and 9, 3, you might notice those numbers on the left might look a little familiar. When we were breaking down radicals before, these were the numbers that were in my radical reds, okay? My perfect squares. And these were the numbers they turned into when they got out of radical jail. That's all that we're doing, basically, anytime we're graphing a square root function. We're just taking these values, and they're all going to be square roots. So, instead of us having to memorize all these fancy things, okay, because as I move down a little here, I have this funky looking math equation. Okay, we use this in some of the math classes. You're like, whoa, x minus h plus k, what the freak are you doing? Okay, English only. The value that's under with x, under the square root, determines if my graph's going to move left or right. Okay, the value outside is going to determine if I go up or down. So here's how this works. Let me get the graphing calc up here so you can kind of see how all these things happen. Because a lot of the times being able to see what's going on is the key to having anything make sense. So let me get mine up here. A lot of work to go through just for a calculator. All right, so here's what I mean. Okay, if you hit y equals on your calculator up here, you should get a screen that looks like this. When I get here, for me to type in what I'm looking at, we'll just look at a basic one first. I'm going to look at the square root of x. Now to get square root, I hit second, and I hit x squared, okay? So second x squared will get me the square root logo. And there's a parenthesis there, and that's okay. Then I just type in whatever I want with it. So since I'm going to just look at the square root of x, you see this x, t, theta, this thing with all these bunch of different letters on it? If you hit that, that's my x button, okay? And once I hit that, if I just close my parenthesis, that's what I'm going to graph first. And it's going to give me a graph that looks like this first one that we were looking at. So if I hit graph, okay, looks like the one that's there. Here's the thing that's cool about it, though, and it's going to make your life easy. If you want to see what numbers are involved in making that graph so we don't have to plug them all in and figure it out, if I hit second and graph, that's going to give me a chart. Now that's my friend in this. Second and graph, and you'll notice, you're like, okay, 0, 0, 1, 1. If I move down to where x is 4, okay, y is 2. How'd I get this?
No,
this chart? Hit second, and then hit graph, and the chart should come up. And you'll notice, now you're like, well, there's some funky numbers in here too. I'm not worried about those. I'm only worried about the ones that come out nice. So 0, 0, just like I had here. 1, 1, all right. 4, 2, that's good. And if I scroll down a little bit more, okay, there's 9, 3. I'm just going to use whole numbers to make my graphs. But here's what I want you to be able to see. If I go back and hit y equals again, okay, I'm going to keep my square root of x graph here. And I'm going to hit down arrow because I'm going to graph two things at once. We won't do this all the time, but I want you to be able to see how this works. So when I get here to x plus 5, I'm going to show you how it works mathematically first, then we're going to visually see how this goes. If I look at the number that's underneath the radical, okay, that tells me whether my graph is going to shift or move right or left. Now this seems weird, and it's not a typo, If it's plus under there, that tells me my graph is going to move left 5. Every single one of those values is going to shift left 5 when I do this. But I want you to see how it works. So here's how this goes. Get our square root up again. So second x squared, because you see the little square root sign right above it in yellow. And now I'm just going to type in what I see here. So x plus 5. Then I'll close my parentheses because I want the calculator to know I'm done. And we're going to look and see how this happens. And you're going to kind of visually be able to see how this goes. So it'll pop the first one up. And now there's my new one. Now it might be a little hard to see in the initial graph, but my first point has moved from 0, and it moved over 5 spots. If I want to see numerically how that happened, right, this is my initial graph, this guy right here. My new graph, every value shifted left 5. Because if I look at the chart, if I hit second graph, okay, my initial values, okay, you're like, okay, well that's 0, 0, but these are all funky numbers. You know, what's up with that? Okay, if I move left 5 from where 0 was, thank you. If I move left, notice what my y value is. It's 0 now. If I shifted left, what's okay, because let's think about this for a second. If I started originally, let me make a quick sketch of my graph here. My first point originally, in my original graph, the one that we had up here, and the one that I made first, was at 0. So when x was 0, y was 0. Right, because when I look here, it's kind of, I'm trying to figure out the best way to explain it mathematically and keep life simple. Whatever you see under here is kind of, you'd think positive 5. If I'm moving on x to go to the right 5, right? But the formula here says I'm subtracting that. So it makes it become the opposite of what you would think. Yep. Yep. It always does that. So all I have to really understand here is that whatever number is underneath this square root tells me if I'm going left or right. If it's positive, I'm going to go left.
But then it turns into a negative.
And then, right, because what happens is it does the opposite. If I go left 5 on a number line, as I go left, it becomes negative. So that's how that kind of works.
Oh, okay.
Okay? So this one just said I moved left 5, and now I start my graph. Here, notice it's not underneath the square root, this minus 7. So if, and again, you won't have to do this on every one, but I want you to see again how it works. I'm going to clear that last one out. If I just hit clear, it'll wipe the whole thing out for me. When I type in this next one, and watch, because it's a really kind of detail here. Notice, remember how we put parentheses in this one? When I do this one, second x squared gets me to here. I only want the x to be in here. So when I do the x, I'm going to close the parentheses right away, because I only want this part in there. And then put the minus 7 after that. And what's going to happen is my entire graph is going to shift down, because if it's outside the square root, it goes up or down. So if I hit graph, notice now my graph started down here. And if I were to look at the chart, I'd see that it shifted down 7 slots for each thing. So I just want you to be able to see what's going on here mostly, because I'm just going to use the chart to copy things, and we'll get to that in a minute. You got a different graph? Now did you, okay, now look at your y. Did you close your parenthesis on your x? Did everything I did. All right, let's check this out for a second. Yes. Ah, somebody messed with your window.
It was me.
You messed with his window? All right. Yeah, if you ever get a graph, when we put one up and you're like, wait a minute, I'm not seeing that, my Algebra 2 students are doing something different. Sometimes they change the windows around a little bit. So we may have to get them back to normal. So if you have that, just let me know. I can get them fixed up real easily for you. Okay, but that's what I wanted you to just visually be able to see how this works. So when I get down to here, and I'm going to keep this little note here handy. Any value under the square root, okay, if it's minus, we shift right that many. So if I'm just asked for the shifts, I'm going to go right 1 in number 1. Okay, I'm going to do all of those first. Which direction and how many am I going to be going with this minus 3 here?
Right.
Okay, right 3. I'm just looking at the ones that are under the radical right now. What about this one? Left 4. And what about number 4 here? Left 2. Okay, so whatever's underneath the square root, always a left or a right shift, nothing else. And it's kind of the opposite of what I would think. So just kind of keep this handy to give you some direction. Now the number outside tells me up or down. So what am I going to have in this first one? Up. Up 2. What about this one? Down 2. Okay, what about in 3? Down 3. And up 1. Okay? So basically, we just learned half of this whole unit. It's just understanding that the number underneath shifts to the left or right, and the number on the outside helps me to shift up or down. Because when it comes to the graphing part, we're going to let the calculator do all the work. Okay? So, as we flip over, I just did a couple of things up here at the top. Okay, just on pressing buttons in the calculator. So press y equals, we've already done this, but I'll bring it back up so we can do them all again here. Yep, we're going to clear everything that we see here. So the up and down arrows will get me back and forth, but then I can just hit clear. And then again, second and x squared gets me the radical, the square root. And then you just type what you see. And again, I kind of mentioned some of the things that we started to do at the front. So when we do these, and we're just going to go back to our plain old square root of x here again, because that's my example we've got over here. We're going to graph that. Now, I don't want you to just hit graph and then kind of half just sketch something on here. I want you to get some accurate points. So that's when we're going to hit second and graph to get the table up. And we're only going to graph the ones where I get whole numbers over here in y. Well, at least as far as we can get on our graph, because you notice my graph only goes to 10 in each direction. So like 0, 0, okay, I can do that. And I can actually put that in my chart here. And then 1's got a whole number. That works. So over 1 and up 1, put a dot. So I keep going, nope, nope. Oh, yep, this one has a whole y value. So my x is 4 when my y is 2. All right, so right 4 and up 2, because again, the 4 is my x value. This isn't slope, it's just plotting a point. And let's see if there's any more before I run out of room here. Oh,
What did you do? Up 4?
nope, right 4 and up 2. Because when I'm doing coordinate points, my x value will tell me how far to go left or right, and my y will tell me if I've got to go up or down. And then the last one that fits in my graph is 9, 3. And once I get them plotted, I just connect the dots and put an arrow on the end. And that's the...
9, 3, you can't go.
Well, but remember, we're going right 9.
I know I have no room to go.
On here, I think you do, because I think this goes all the way over to 10. You're starting over at 0 every time.
I know I did.
Oh, I wonder if I was getting confused. Oh, okay.
Okay, so we're just taking the whole numbers that we've got for each one, kind of working them through that way. So here's the one other thing we're going to do with this. And this is the thing that gets a little trickier. When I get to this part, there's a way for me to describe all of the possible x and y values that you could get with this. So here's how this is going to work. Let me shrink this down here for a minute. There's a thing called domain and range. Okay? Domain is the possible x values that I can get when I'm graphing. And the range is my possible y values that I could do. So when I'm doing domain, I'm going to start at the leftmost point of my graph, and I'm going to go to the right. Now here's how this works, because you're like, well, go to the right, that arrow, it's just going to keep going and going and going and going forever and ever and ever. That's true. So if you see an arrow and it's going to go forever in a direction, that's called infinity. It's kind of a sideways 8. It almost looks like a mask that you might look at, you know, from a cowboy, from like the Lone Ranger or something. It's just a mask. Looks like maybe like a raccoon's face even. Or we can just look at it as a sideways 8. Yeah, I was going to say, you probably see this in some other classes too. So my domain, where does my graph start as far as x values go? Well, it looks like it starts here at 0. So I'm going to use a parenthesis. I'm going to put this 0 in. And if it just goes forever and it never is going to stop, and that's what the arrow says, it's just going to keep going and going and going, we're going to use our infinity sign to say my x values can start at 0, but they can go forever after that. I could find out the value of this if x was 1,000,000, 10 million, 100 million, doesn't matter. I could find an x value. Okay? I could get a value for that. So that's if I'm just looking left to right. Okay? My range is my y values. I go from the bottom of my graph to the top. So here, my lowest value, or my least value for y, also ends up being 0. Now they won't be the same every time, and we're going to find that out. Once I start that at 0, this, if I were to see it in a little bit bigger of a picture, because it kind of looks like this is leveling off, but if we were to notice, it's going to keep going and keep increasing and getting bigger and bigger and bigger. So it also goes up forever to infinity. And you're like, is every single one of these going to have infinity? Yes. When we have a square root function, there will be. So it's basically that first number that I'm going to have to work with. Okay? Because here's the other thing that might help you. If you're not sure sometime on your domain or your range, you're like, wait a minute, if I start going up, what's all this error that keeps coming up? Error means there's no value, there's no y value for that. So what that tells me is once I start running into error messages, I can't go that direction any further. So 0 is the last x value that I get a y answer out. That's why I start my domain with 0. 0 is the lowest y value I get before errors start. That's why I start my range with 0. And you can do that on every one of these. So you always have the backup plan of using the calculator if you need the help. So when we go to graph, okay, we're going to kind of put these things together. So if you've been kind of watching, jump in on this one. We're going to clear out again. We're going to start up again. So second and x squared gets me my square root logo. And I want this x plus 1 inside my square root. So x plus 1, again, the x is this button up here next to alpha. And then close your parenthesis, because we don't want that minus 3 in there. Notice it's outside. So I got to be really accurate. Oops. As I say really accurate, and then don't have it. There we go. So now, I'm not even going to bother going to the regular graph. I'm going to go straight to the table. So I'm going to do second graph, gets me the table. And I can start looking. And I'm like, okay, where do we start here? My good points, and I'm just going to write them down, looks like -1, -3. So I'd go left 1 and down 3. Put a point. Let's see, what else? Whole numbers for y only. Okay, so 0, -2. 0, -2. Let me keep going here. Okay, there's another whole number for y. So 3, -1. And some of you may be thinking, do I have to write these good points down every time? No, but I want you to have a copy where you see where they're coming from. Let's see if there's any more before we run out of room here. Oh, there's one more. 8, 0. And once I run out of points that are whole numbers, connect the dots with an arrow on the end. Okay, so we're letting the calculator do all the work for us. Here's where we also let the calculator do the work for us. Remember when we're talking about domain and range, we're always going to end up having infinity involved. So let's see, now where's this step? Oh, error messages start. That tells me my domain and range basically. Where do my x's stop where I can't go any further? -1's the last one. My graph starts at an x value of -1. Okay. And then the arrow tells me it goes off forever to infinity. Well, how do I figure out the range? I can look at the graph. It starts here at -3. Or I can look on my chart here and say, ooh, -3 is the last y value before it turns into error. That goes off to infinity. So let the calculator, all the information will be there for you. It's just trying to look at it and understand where it's coming from, is what we're trying to do.
Hey, can you explain how you get the Python phenomenon?
How I do these guys? Okay. 2 ways I can do it. I can either, once I've plotted all my points, I can look for the leftmost point on my graph. So I notice this dot is where x is -1 because it's 1 to the left here, and that tells me I can start here.
And then just goes on forever. That's not easier than
Right,
that.
and it goes on forever. Or if I still have my calculator chart up, the last x value that's in here before it starts the error messages, that'll also tell me where my domain starts.
So wouldn't it be like, I would get confused and write -3.
Okay, but remember, when I'm thinking about domain's my x values. X value is how far have I moved left or right, because I know you see down here it's -3.
See the first one and then I'm saying go on forever. Doesn't it always go on forever?
Yep, always going to go forever.
Right, that's all.
And then it's the same with the range. -3 is how far up or down did I go? I went down 3 to get to that point, and that's where we're starting. Now I'm going to skip 2 for right now. 'Cause
How
that's,
far you went there? Is that-
yep, how far did I go down to start? So all I'm going to do, okay, I'm going to come down to 3 here for a minute because it's a little easier to play on the picture here. All right, let me clear this out. This 2 is in front, so I'm going to put the 2 in there first. Then comes my square root. So second, x squared. And again, you'll always have access to this note sheet, and there's directions on even how to do this. So if, you know, you tend to forget how to punch things in, just keep this handy. Close my parentheses after the +1 because the +3 doesn't go in there. Make sure this looks the same. Looking good. And then second in graph because we want points. So this time, let's do this. Let's do our domain and range first. So I look, I'm like, okay, error, error, error. Oops, here's my first spot where it's not error. So -1, +3. And that tells me my domain is starting at -1 and going to head off to infinity. And my first y value being 3 tells me I'm going to head from 3 to
That's
infinity.
a good point.
So I don't have to write every one, but to graph them, I want to make sure I put them all here. So like 0, 5. I'm just going to keep writing them in just so I have an idea of what's going on here. Oh, let's see. We're going to have any more to play with? Oh, there's one. 3, 7. And we always want to check till x equals 10 just to be sure. Oh, there's one more. 8, 9. Usually you'll get 3 or 4 of them. So write 8 and up 9. Boom. Got my graph. Could figure out domain and range from there. Because again, domain is my x's. Range is my y's. And I'm just going left to right or top to bottom, like we mentioned up above. So let's slide. We'll slide here momentarily. We're going to go to 4 and then up to 2. 2 is kind of our bring it all together problem. But just keep letting the calculator do your work. Let me get back to y equals here. Now I'm not going to retype everything because I see I've got that 2 in front, but I already have that. So we've got x plus 3 in the parentheses. Oh, and plus 3 on the end. All right, just one little quick move. Make sure we're the same. Yes, we're good. Let's get our table up. I don't see error yet. Let's go find error. There it is. So again, once I find that error message, I'm going to plot my points here. So I got negative 3, 3. So I'm going to go left 3 and up 3. Put a dot. I've got one at negative 2, 5. And 1, 7. Let's see if they give us any more here. And 6, 9. And again, when it comes to domain and range, I can either steal it from the chart and say, okay, there's my first values after error. So my domain is negative 3 to infinity. And then the y value tells me where to start for my range, even though I can see that on the chart even. There is one exception to the rule, just one. Okay? And that's going to be the last example we do here. But otherwise, this isn't going to change on you. And that's going to make this nice to deal with. All right, last one. I'm going to clear this out. Negative 3, and make sure you use the negative button next to enter, not minus, or you'll get an error message. Second x squared. So I want x minus 2 in the parentheses. And then plus 1. Okay, are we the same? Yes. Okay. So let's see what's going on here. Oh, that's lots of error. Error, 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 error. Okay, we got away from error. Now, I'm going to plot my points this time first, before I do anything with domain and range. So we're at 2, 1. Okay, let's get up here. We're at 3, negative 2. Now this one's a little different. Looks like we're opening down this time. 6, negative 5. And are we going to get one more? Well, not really, but I'm going to use it. I can go one off. 11 and negative 8. Here's where things change a little bit. It's not going to mess with my domain. If I come back up to where the error messages started, my domain's going to be the same. I'm going to start at that 2, and I'm going to go to infinity. Here's the one change. My range isn't going up anymore. It's going down forever. If you see something going down forever, the opposite of going positive forever is going negative forever. So negative infinity. And then I still am going to use the one that's there. Okay? This is the one exception to everything we do. If you get a graph that opens down, your range has that one tweak. Otherwise, this never changes at all. Never, 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 ever. Okay? And I absolutely get that this is one that you're probably going to have to do in class because I don't know how many of you have graphing calculators otherwise, even though these are available online. Like this one that I have up right now, you can download for free, okay, if you've got something at home. It's actually on the front page of my website where you can go, click on the link, you download it, and bang, here you go. You've got the exact same calculator we have in class at home on your computer. But otherwise, excuse me, you'll have the rest of the time today and all class tomorrow to work on this stuff in here, where you don't have to worry about dealing with it outside of class if that's an issue at all, okay? So, our task to get started with, and this is just me, I would probably save the shift problems for later because you really don't even need the calculator for those. I would start typing some of these on the calculator just to get going. Use your good points, just like we were doing. And then you can do your domain and range just like we've got on the graph here. And so basically, it's just the same thing as we've been doing, okay? And don't let something strange, because some of you may, as you're getting a little further along with this, see number 7 and go, well, wait a minute. Why is the 3 first? Is that, you know, is that going to mess things up? No.
They all have the same slope.
They all have the same sort of, not necessarily slope, but they have the same type of curve to them. The only thing that'll ever change what type of, you know, depth or slope they have is if there's a number in front. That can make it wider or skinnier. But yeah, they're always going to look the same type of way, though. It's always just going to be that plain old kind of half curve that's working on every one of these. But every one of these, like if I was doing number 7, is going to work the exact same way that we've been doing these so far.
For number 10, do I put 1 divided by 2?
Here's how I would, let's do that one. Let's do 10. Kind of get you a kickstart here. I would do 1 divided by 2 if I punched on the calculator, it'd be 0.5. I'd just use the 0.5. So 0.5 square root of x plus 1. Because again, I only want the x plus 1 in the radical, so I'm going to close it. Plus 4. Let's see what this does. Second graph. All right, there's my error messages starting. So my good points would be at -1, +4. Go down a little further here. 3, 5. This may be one of those that I only get 3 points. And, oh, I only get 2 points because 15, that's way off the chart. Okay. So you notice it's kind of thinner. It almost looks like a straight line. It's not quite. But just like I've done on every other one, it opens up, so it's not the special case. So, okay, there's my error messages. So there's my domain value, my first x value, and my range value, which is just starting at my first y. Let the calculator do the work. You just have to be able to pluck information off of it is all you've got to do. And then we'll be good to go on those. Okay. So that's, and even if it's just doing a couple right now, just do a couple so you get used to the button presses. Because once you get those out of the way, I think you're going to find this is pretty easy to work with. We'll be talking about them again tomorrow. But just try to maybe just knock out even the first couple to give yourself a little leeway, and we'll start up again then.